Hello, this is Mrs. Dubois, and I'm going to deliver or talk about, the notes for the second half of functions, all right? And there is some new terminology today. We will discuss what is a function, and then we will see a fancy way for writing function notation. So according to yesterday, if it's a function, every input yields one output. Right. So if we look at example 1, table B, right, you will see that every input maps out to one output. So yes, this is a function. Then we'll look at example 2. When you have these ovals and you have to evaluate the input to the output, I like to write it out actually in table form, just to make sure that I don't miss anything, because sometimes there are many arrows going in many different directions. You don't want to miss anything, okay? And again, we're testing, does every input have exactly one output? And it does. So that is a yes too, okay? Table 3. Again, you're looking at the input. Does each input map out and have one output? And the answer is yes. So this is a function. The last one, example 4, asks you if you have where you can drive on 1 gallon of gas. Again, I like to draw out a table, right? So this is my input. This is my output. Now, if I have 1 gallon of gas, I was thinking, if I'm at my house and I have 1 gallon of gas, I can potentially drive to Dunkin'. Also, though, if I have 1 gallon of gas in my car, I could also take my children to the park. 1 gallon. Or I could drive to my friend's house. Many other things I can do, but as you can see here, 1 gallon can map out to more than one output. So the answer here is no, that is not a function. Now we're going to introduce function notation. This is kind of like if you become a medical doctor, we can start to call you doctor. It's just like a little formal term. It doesn't change who you are. It just makes you a doctor. We just call you something a little more formal. So we have seen function form y equals mx plus b, correct? And now we can replace that y with f of x. These two equations mean the same thing. Make that be a little better. Okay, and with that comes the ability to evaluate. All right, so this is in function form, y equals 2x plus 1, and then it becomes f of x equals 2x plus 1. Again, we're substituting or replacing the y with f of x to get a little more formal. You will frequently see it like this, and then you have to evaluate. These have diamonds. It just didn't come out to explain everything. So if I want to input, if you look on your notes, you have diamonds in there. A diamond is going to look like this. Everywhere I have x, I'm going to input a diamond. So I'm going to rewrite it. G of a diamond, when I replace it, and if I put the diamond in there, I cannot combine like terms. Right? So same thing here. This one's kind of unique because h of diamond equals 7. And then if I have j of a diamond, this equals 3. diamond squared plus 1. And again, you can't, not a fancy enough diamond. You can't really evaluate or combine like terms there. Okay, now this means f of heart, where you have an x, you're going to replace it with a heart. In your same thing, g of x, g of heart, you're putting in a heart everywhere you have x. And then we can combine like terms, but there are no like terms in this one. So I'm going to start again because this one's kind of unique. H of heart equals 7. And then J of heart equals 3 heart squared plus 1. All right. Now, if we plug in a number, like f of 2, we're going to plug in the 2, and then we're going to use the orders of operations to evaluate. 4 plus 3 is 7. So f of 2 is 7. Here, same thing, g of 2, we're plugging in a 2, and then we're going to evaluate. Negative 6 plus 1, negative 5. H of 2 equals 7. Everything in here equals 7, if you notice, going down this column. And then you have J of 2. So it's 3, plugging in a 2 for x. Then if I evaluate according to the orders of operations, I have to square. And I'll have 12 plus 1 equals 13. Now, f of y, I should have been changing colors all along, just make it clear, but here we go. F of y, so I'm plugging in 2 times y plus 3. It stays that way because you can't evaluate that any further or combine like terms. Same thing here. We could spiffy it up a little. And here, the same thing, f of y equals 7. I'll put a 7 up here. Then, I thought that was y plus 1. I think this didn't come over right. We're going to put in y, so it equals 3 times y squared plus 1 equals 3y squared plus 1. Okay. 3x squared. Oh, this one's going to be a little tricky, as I cannot see. 2x plus 3. This one's 2x plus 3. This is negative 3x plus 1. This is h of x equals 7. And this one plus 1 is j of x equals 3x squared plus 1. All right, so this one is where the fun begins. We're going to plug in. I'm going to change my color just so it's clearly stated. All right, so we're going to plug in x plus 1 everywhere we have x. So this will become 2x plus 1 plus 3. Then we will apply the distributive property. So it's 2x plus 2 plus 3. So you keep evaluating, simplifying, okay? That equals 2x plus 5. Now we're going to have negative 3x plus 1 plus 1. You're going to have negative 3x minus 3 plus 1. Negative 3x minus 2 when you follow the orders of operations. Okay. I'm going to circle these, put a square around these. Okay. Then you have this one. And once again, everything in this column equals 7. And then you have this column. And this is 3x plus 1 squared plus 1. Now this one's a little different because we haven't seen a binomial, two terms, squared. But what we're going to do is double distribute. Okay? I'm going to do this step in red. If I write this out, okay, it looks like this. All right. Now I'm going to double distribute. So I'm going to distribute the x, okay? I have to rewrite my 3. X times x is x squared, x times 1 plus x. Then I'm going to distribute the 1. 1 times x is x. 1 times 1 is 1. Close my parentheses because that's everything dealing with the double distributive. Then I'm going to distribute again. I should combine like terms actually first, right? Then distribute the 3x squared plus 6x plus 3 plus 1. And then keep simplifying all the way to the end, okay? I get 3x squared plus 6x plus 4. I'm going to wipe this away. Okay. And now we can also go back to getting our ordered pair, because remember we're dealing with functions, and functions can generate ordered pairs, which we graph. So again, you are plugging in the number. This says f of 1, and so you will plug in. So f of 1 equals 1 plus 6, which is 7, and then the ordered pair is 1, 7. Then you have f of 3. F of 3 equals 2, meant to put a 3 in there. Squared plus 1. So you have 2 times 9 plus 1. So this is 19. This will become 319. Okay. Then we have f of 9 equals 2 times 9 plus 1. So interestingly enough, this is 18 plus 1 when I follow the orders of operations. And this point is 919. Then the last one, we're plugging in 12 for x. So we have 1/6 times 12 plus 2. 1/6 of 12 is 2. So it ends up being 2 plus 2, which is 4, which is 12, 4. Okay, so today the emphasis is on function form, which is f of x, replacing f of x with y, which is just a formal way of addressing functions as we become more precise mathematicians.